Okay, first of all, create this topology on GNS3. Three routers, two switches, generic switches, and two PCs. PCs, you can use Linux PCs, for example, Body Linux. Instead of using serial 000, I will use serial 30 to serial 30. Serial 001. Instead of using serial 001, I will use serial 31 and serial 31. Gigabit 00. Gigabit 00. On R2, Gigabit 00 to switch 2. Connection between switch 2 and switch 3. And connection from Gigabit 01 on R3 to switch 3. Instead of using Gigabit 01, I will use Gigabit 10. The above topology has been perfectly configured for you by the NetLab system. All devices have the default passwords: console Cisco, encrypted privilege exit password class, remote access SSH, username user, and remote access SSH password Cisco. IP addressing scheme in the topology: a total of 5 IPv4 networks and 4 IPv6 networks are shown, with the following IP addresses. Okay, remember the connection for the GRE tunnel from R1 to R3. This green section, this green tunnel, will use the IPv4 10.111.99.0 subnet mask theory. First of all, configure the addressing. Start all devices. configure one, configure terminal interface gigabit 00. Okay, the first IP on this network IP address and subnet mask. Also, first IP on IPv6 no shutdown. Serial 030 serial 30 IP address you can use the first IP here, so the second IP on the another side. But the subnet mask 252 IPv6. This is a. You can use the first IP prefix 64. You can set a clock rate mark question to be the options and select the highest value. Then no shutdown. Exit and don't forget to enable IPv6 routing. Sorry, IPv6 Unicast routing. R2. Configure terminal interface serial 30 IP address. The second IP on this side 200 IPv6 address A264. No shutdown. Configure serial 31. Serial 31 IPv4 address 200 223. The first IP in this side 252 IPv6 B1. No shutdown. Exit IPv6 Unicast routing. You will configure Gigabit 00 on R2 later. R3. Configure terminal interface serial 31 IP address. This IP address on this network IPv6 address B2. no shutdown. Gigabit 00 interface Gigabit 00 IP address. First IP on this network first IP and 24. Then IPv6 address first IP. Okay, A. No shutdown. Exit IPv6 Unicast routing. You will configure Gigabit 10 R3 later. Configure point-to-point protocol between R1 and R2 according to the following specifications. On R1 and R2 serial 0 interfaces, in my case serial 30, encapsulation, CHAP, and create a local database entry for CHAP, authentication, username, R2, Cisco, the password, and the database entry for CHAP on R2, the username R1, password Cisco. Go to R1. I'm using interface here 30. Encapsulation point-to-point protocol. Then point-to-point protocol authentication CHAP. Exit and create the username for the another side. Username R2, password Cisco. Okay, go to R2. Interface serial 30. Encapsulation point-to-point protocol authentication. Okay, authentication CHAP. Exit, then the username will be R1 and the password will be Cisco. Remember, be sure that the hostname on R1 is R1 uppercase and the hostname on R2 is R2 uppercase. So on R2 you are configuring the username R1 uppercase and password Cisco, and on R2 you are configuring R2 uppercase with password Cisco. Configure IP routing. Configure on R1 IPv4 default route to serial interface 0. Okay, R1 IP route, the default route 1234 serial 30 in my case. Enable IPv6 routing, already configured IPv6 unicast routing. Enable EIGRP for IPv6 routing on router and router ID. The autonomous system 1 and router ID 1. IPv6 router EIGRP 1 and EIGRP router ID not shut down. Configure the appropriate IPv6 interfaces for EIGRP, Gigabit 00 and Serial 0, Gigabit 0 and Serial 0. Exit IPv6 EIGRP Autonomous System number 1. Interface Gigabit 00 IPv6 EIGRP Autonomous System number 1 Serial 30, the same command. Same configurations on R2, but the router ID is different and on both serial interfaces. Serial 0 and Serial 1. IPv6 router EIGRP Autonomous System 1 EIGRP router ID 22 not shut down. Exit interface Serial 30 IPv6 EIGRP 1 and Serial 31 IPv. Okay, this is the neighbor adjacency Serial 31 IPv6 EIGRP 1. All three use a different router ID and Gigabit 00 and Serial 1. Gigabit 00 and Serial 1. IPv6 EIGRP Autonomous System 1 router EIGRP Autonomous System 1 EIGRP and router ID not shut down. Exit interface Gigabit 00 IPv6 EIGRP 1 and Serial 31, the same command. Okay, this is the neighbor adjacency, and don't forget to configure an IPv4 default route on R3. Exit IP route Serial 31. Okay, use the interface Serial 1 and the administrative distance of 200. Okay, Serial 31 administrative distance 200. Enter. Okay, and now verify the connectivity between R1 and R3. Okay, go to R1 and ping the CR31 interface on R3 with this IPv4 and IP address. Ping 200, 200, 223, the second, success. Ping A, B, colon 2, success. And go to R3 and ping CL0 interface on R1. Ping 200, 200, 122.1 is the first IP, success. And using IPv6 A, colon 1. Success. Now, you can continue to the next step, configure GRE tunnel with BGP. On R1, the interface is tunnel 0. Okay, go to R1, configure terminal, create interface, virtual interface tunnel 0, set the IP address, first usable IP address of R1 R3 GRE network. This 10.111.99, the first one, and the subnet mask ends with 252. Enter. On R1, the source is serial 30. Tunnel source serial 30. Tunnel destination R3 serial 1 address. The destination is serial 31 on R3, but use the IP address, not the interface. So use this IP 200.200.223.2. Destination 200.200.223.2. Create a host route to the tunnel destination. Okay, exit IP route. The tunnel destination is this. Use the subnet mask 32 to 25 to 25 to 25 to 25. And use the exit interface serial 0. In my case, serial 30. Now configure BGP. The autonomous system on R1 will be 65,010. Okay, rather BGP 65,010. Set neighbor R3. Okay, the neighbor is R3, but use the second IP address on the GRE tunnel on the GRE network. Okay, set the neighbor and use the IP address on the another side, but on the GRE tunnel network. If interface tunnel 0 on R1 is the first IP 10.111.99.1, the neighbor is the second IP on the GRE tunnel network, 99.2. And look at here, the autonomous system on R3 for BGP is 65,030. Specified remote autonomous system 65,030. And advertise R1 LAN. The R1 LAN is this 10.111.110. And the mask 24. Now go to R3. configure terminal interface tunnel 0 IP address. Okay, if R1 uses 10.111.99.1, on R3 will be 10.111.99.2. Subnet mask 252. The tunnel source interface serial 1. On R3 the source is serial 31 interface. And tunnel destination is the IP of serial 30, 200, 200, 122, 1. Okay, create a host route to the tunnel destination. Exit, IP, exit, enter IP route. Tunnel destination is this. Use subnet mask 32. Exit interface serial 1. In my case, serial 31. Now configure BGP. Router BGP 65,000 theory. The neighbor is the IP address of R1 on the another side, 10.111.99.1. Okay, on the GRE tunnel network, and the remote autonomous system is 65,010. And advertise the R3 LAN. The network on R3 is 10.111.53.0. Subnet mask 24. Okay, and don't forget mask, enter. Okay, very nice. Now, as you can see here, the neighbor adjacency with R1, and on R1 you can see here the neighbor adjacency with R3. So it's very well configured. Okay, now verify connectivity. From R1 and ping tunnel 0 IP address on R3. That is 10.111.99.2. Success. And go to R3 and ping tunnel 0 IP address on R1. 10.111.99.1. Success. On R3, verify the IP route, show IP route, the routing table. Now you can see this network is the LAN network on R1. This network, using BGP. Okay, BGP, and go to R1 show IP route to see the routing table, and you can see the LAN network on R3 using BGP. Now configure PCs, PCA, edit connections, double click here, IPv4, okay, configure IPv4. You can set IP address, for example, 10. Net mask 24, and the default gateway is 1. Okay. Then configure IPv6. Manual add A 1, and you can use column, for example, A. Prefix 64 gateway one column 1. Okay, enter. Save. Restart networking. Disable. Then enable. Open the command line, the terminal, and IP address command. This is IPv4, and this is IPv6. Ping to the default gateway. Success. Control-C to stop, and ping to the default gateway, but using IPv6. Also success. Control-C to stop. Configure another PC. Edit connections. Double click here. IPv4, manual add 10.111.33. For example, 10 subnet mask 24 gateway 10.111.33.1. Okay, and IPv6 manual add A 3, for example, A 64 gateway A 3 column 1. Enter. Okay, save. Close this. Disable networking. Enable networking. Go to terminal. IP address. This is IPv4 and this is IPv6. pings the default gateway on IPv4 33.1 success, and pings the default gateway on IPv6. Success. Control-C to stop. Okay, you will be able to ping from PCA to PCC and vice versa. Okay, go to PCA, ping to PCB. 3A is the IP address of PCB. Success. Control-C to stop. And also using IPv4 as is 33.10. Success. Now, from PCB to PCA, go to PCB, okay, using IPv6 is 1.column A, success, Control-C to stop, and using IPv4 is 1110, success. Very nice. So you can continue and configure R3 as the R3 will be the point-to-point over Ethernet client using Gigabit 1.0, and this connection using switches, and R2 will be the point-to-point over Ethernet server using Gigabit 0. Okay. Okay, on R2, for reference, the indicated configuration has already been applied to R2 for you. Okay, but you need to apply this if it's not applied. And go to R2. This is the point-to-point over Ethernet configuration. Okay, first of all, create the username customer1. Remember, on R2, okay, username customer1, password Cisco point-to-point over Ethernet. Now, the local pool IP local pool, and set a name for this pool, uppercase point-to-point over Ethernet pool, and set a range of IP addresses from 10.0.0.1 to 10.0.0.10. Configure the virtual template. Number 1 is a virtual interface, virtual template. Virtual template number 1, and set the IP address for this virtual template IP address. The last IP 10.0.0.254 with this subnet mask 24. The MTU set to 1000. Okay, set the peer by default IP address pool, and the name of the pool, this name exactly. Okay, the peer will use the IP address from the pool. And the authentication point-to-point authentication chop call in. Enter. Then exit from virtual template interface. Now configure on global configuration mode VBA group point-to-point protocol over Ethernet global. Now you are enable point-to-point over Ethernet but using virtual template number 1. Then exit. And now also enable point-to-point over Ethernet on Gigabit 00, the physical interface. Interface Gigabit 00, point-to-point over Ethernet, enable group global. Then not shut down the physical interface. Okay, now ready. So the server is configured with an IP address and subnet mask with a range of addresses. Also, point-to-point over Ethernet protocol was enabled. Go to R3, then configure Gigabit 10 to obtain an IP address from the server R2. Go to R3, configure terminal. Okay, Gigabit 01 for point-to-point protocol over Ethernet connectivity. In my case, it's Gigabit 10. Okay, enable point-to-point protocol over Ethernet on Gigabit interface. The client uses dial pool number 1. Activate the interface. Interface Gigabit 10 in my case. Remember, I'm using Gigabit 10. And enable point-to-point protocol over Ethernet enable. Okay, and the client uses dial pool number 1. Point-to-point protocol over Ethernet dash client dial pool dash number 1 and not shut down. Okay, now configure the dialer interface. This is very important. Create a virtual dialer 1 interface. Okay, interface dialer 1. Now, negotiate the IP address from R2. Okay, obtain an IP address from the server, IP address negotiated. Okay, set the MTU to 1492. MTU 1492. The same configuration as the server. Okay, and to accommodate the point-to-point protocol headers. So configure the encapsulation point-to-point protocol. Now create dialer pool number 1. Okay, dialer pool number 1. Enforce and assign the CHAP authentication username customer 1 and password Cisco point-to-point protocol over Ethernet. Point-to-point authentication CHAP calling okay, the point-to-point protocol chap hostname is customer one, uppercase C, configured as the server. Okay, the password point-to-point chap password Cisco point-to-point protocol over Ethernet. Okay. Okay, you can see down. Okay, down. Okay, the hostname is customer one C uppercase, and the password is password Cisco point-to-point protocol over Ethernet. Review the server and look at this. The password R2. Review the server and look at this. The username is correct. The username is customer1 C uppercase, but the password is Cisco point-to-point incorrect. Okay, P is missing. Okay, okay. Remove this command and set the command again. Exit. Now username customer1 password Cisco PPPoE. Remove. Then username customer1 password Cisco P point-to-point protocol over Ethernet. Okay, go to R3. Okay, up. Very nice. Up. Now, configure a static default route using the dialer 1 as the exit interface. On R3, obviously, the point-to-point over Ethernet client, IP route, default route, and dialer 1 as the exit interface. Okay, verify on R3 verify and show IP interface brief, and you can see dialer 1, the IP address 10.0.0.0.1, the first IP from the pool, the method IPCP up. So obviously you can ping the server 254. Okay, success. Okay, repeat success. On R1 and R3 configure access lists according to the following specifications. On R1, configure IPv4 extended access list, name it ICMP access. Okay, and deny all pings to the R1 LAN. Okay, configure terminal, IP access list, name it, extended, but name it ICMP access. And deny all pings to the R1 LAN. Okay, this is R1, deny the access to this LAN. Deny ICMP from any source to any destination, the EIGRP. Place the access list at the correct interface and direction. So you will apply on Gigabit 0.0 interface. Okay. Okay, now this entry is denying all ICMP access from any source to any destination, but permit any other protocol or traffic, permit IP from any source to any destination. Then place the access list at the correct interface and direction. The correct interface is Gigabit 0.0 on R1 because the destination is this LAN. And if the destination is this LAN, is outbound traffic. Okay. Exit interface Gigabit 0.0. IP access group, the name ICMP access out. Enter. Okay, the same name as the access list. Now on R3, configure an IPv6 standard access list, name it limit access. Go to R3, configure terminal IPv6, the access list limit access, and deny all pings to network R3 IPv6 LAN. Okay, this the destination network AAAA3. Okay, and deny ICMP from any source to the destination three. Prefix 64. Echo request. Okay, then permit any other traffic. Permit IPv6 from any source to any destination. Okay, enter. Then place the access list at the correct interface and direction. Okay, the correct interface is Gigabit 0.0 outbound. Interface Gigabit 0.0 IPv6 traffic filter. The name of the access list limit access out. Double C. Okay, the same name as the access list outbound direction. Then finally configure simple network management protocol version 3 authentication using access list on R1 according to the following specifications. Go to R1, create a standard access list to permit only the LAN containing PCI. So use this name SNMP-access. Exit IP access list standard SNMP-access. Then permit only the LAN. The LAN is this 10.111.1.1. Permit 10.111.1.1.0 and use the 24, but use the wildcard. Okay. Using the SNMP server view command configured and SNMP view include specified MIB. Okay, the SNMP view will be called SNMP dash read only MIB included ISO. SNMP server view, the name SNMP dash access. I'm sorry, SNMP RO ISO included. Okay, using the SNMP server group command, configure the SNMP group. SNMP version with authentication and encryption and limit access using the access list. The group is SNMP version 3, authentication and encryption required. Access read-only by using the access list previously configured SNMP access. SNMP server group SNMP version 3. Okay. Okay, the privilege read the name of the view SNMP-RO access and use the access list previously configured this SNMP-access enter. Then configure the authentication and encryption. Okay, SNMP server, you can create a username, call it admin, and for the SNMP group, the version 3, the authentication SHA, for example, and the password can be admin123. The privilege, the encryption AES 128, and this password will be admin321, for example. This is the password for the user, call it admin uppercase, and this is the another password for the encryption using AES 128. Enter. Okay. Thank you very much.